Okay, so for the first part of the lesson, you're going to take notes. This is what we're talking about. How do we solve, how do we solve all types of linear equations in one variable? We're going to talk specifically about the idea of simplifying each side of the equation as a strategy in order to solve the equation. Okay, so you want to pause the video for a minute and do the do now problems. Okay, we'll talk about them tomorrow. Okay, so some terms that you have to be aware of is the word term. So what we mean by an algebraic term is an algebraic expression that is a number, a variable, or the product or quotient of numbers and variables. So a number, so it could be 3, for instance. This is a special type of term called a constant. Okay, a number without a variable is called a constant. So it can be a number, it can be a variable like x or y. It can be the product of a number and a variable, so 3 times x, that's also a term. Or, 5 times y. Or 5y squared is also a term. It can be the quotient of a number and a variable as long as the variable is not at the bottom of the fraction. So it can be y divided by 5. Something that's not considered a term is when the variable is at the bottom. That's not a term. Okay, so like if you had 6 over x squared, that's a different type of thing. Okay, that's not considered a term. Now, a first degree equation is they contain two types of terms. Constant terms, like we said, any number that doesn't have a variable is a constant term, and terms containing the variable to the first power only. This is super important. Okay, so in this equation right here, the x is the variable, and it's only raised to the first power. And that's really important. In this one, we have an x and we have a y, but all of them are raised to the first power. Okay, something that's not a first degree equation would be like x squared plus 2x equals negative 3, for instance. Not a first degree equation because of this 2 right here. That 2 makes it so that it's not a first degree equation. It actually makes it what we call a second degree equation. Okay, another example of a first degree equation would be this one right here. So we have 6y plus 9y is equal to 20. We're going to end up considering those like terms because they have the same variable raised to the same exponent. Okay, now this is the first degree equation because every variable I see, this one and this one, are raised to the first power. The equation below is not a first degree equation because a variable in the equation is raised to an exponent greater than 1. So there we go. This is actually called a second degree equation. And we'll learn about those later on in the year. Okay, another piece of vocabulary is like and unlike terms. So 2 or more terms that contain the same variable, or variables, so it can be 1 or more, with corresponding variables having the same exponent are like terms. So let's just give you an example of like terms. Like 6k and k are like terms because they have a k and the k is raised to the first power. Notice they don't have the same coefficient. So 6k has a coefficient of 6 and k actually has a coefficient of 1. Okay, you don't write it, but it does have a coefficient of 1. So because they both have a variable k, and the k's are raised to the first power, 6k and k are considered like terms. 5x and 7x squared. I'm sorry, this is 5x squared and 7x squared are like terms because you have x squared and another x squared. 9ab and 0.4ab because they both have an a and a b, and both a and b are raised to the same exponent. Something that would not be like terms would be like 9ab, and if you had let's say you have the same coefficient 9, and you have an a, but the b is squared. These are not like terms. Okay, doesn't matter if the coefficient's like. What matters is the combination of variables and exponents that the variables are raised to. So this one has an a to the first power, this one has an a to the first power. Everything's okay, except when we get to b, b has the first power, and the b over here has the second power. So that makes it not like. All right. Similarly, 9/2 x squared y to the third and negative 11/3 x squared y to the third. Again, the coefficients don't matter. What really matters is that they each have the same combination of variables and exponents on those variables. They both have an x squared y to the third. Okay, so some examples of unlike terms. Let's use a blue pen for this. Some examples of unlike terms would be 3x and 4y, because that has an x and that has a y. Notice they both have variables raised to the first power. You know, in 3x, the x is raised to the first power, and in 4y, the y is raised to the first power, but you have to have the same variables and the same exponents. 5x squared and 5x to the third, even though they have the same coefficient, 5, and they both have x's, this 5x squared is raised to the second power, 5x cubed is raised to the third power, so they are not like terms, they're unlike terms. Okay, same with 9ab and 0.4a. This one doesn't have a b. If it did, they would be like terms, but since this one has an a and a b, and this one only has a b, then they're not like. Okay, this one right here and this one right here are not like, because this x cubed is raised to the third power, and over here that x is raised to the second power, right? We go on further, they're further unlike because this is a y squared and that's a y to the third. So not only do you have to have the same variables, you have to have the same exponents on those particular variables. So if it were x to the third y squared for one term, it would have to be x to the third and y squared for the next one for them to be like. Okay. Now to add like terms, so like let's say that we have 4x and 8x, and we want to add them. Then what we do is we use what's called the distributive property. All right. Distributive property says that, well, when you have the same term, you can pull the coefficients out to be 4 and 8. 4 plus 8 is 12. So if we have 4x and 8x, we have 12x. Okay. Likewise, if we have negative 3/4 d and 4/8 d, we could pull just the coefficients out and put them together in their own parentheses and put the d on the outside. And then negative 3/4 plus 4/3, well, you have to make the second fraction. To add fractions, you have to have common denominators, so you make the second fraction over 4. And then negative 3 plus 2 is negative 1. Okay, and that's still over 4. So you have negative 1/4 d. Okay, so to see what that strategy looks like in action in order to solve equations. So for this equation, the thing that's different about these equations from the ones that we did on Friday is that you have to clean up the sides before you move on. So for this one, you have to clean the sides up. So if there's any like terms that are on the same side, you have to deal with them. So I'm going to erase that for a minute. So these two are like terms. So I can say, what I can think of, just think of their coefficients. They're like because they both have x's, and their x's are both raised to the first power. So 5 plus negative 6. Okay, well that's negative 1. So you have negative 1x plus 8 is equal to 24. All right. Well, now we have, there's nothing, we can't add anything else on those sides because they're unlike terms. This 8 is a constant, and this one has a variable. All right, so you can't add those together. So we can, now it's like the equations that we solved on Friday. So let's subtract 8 from both sides. Okay, we have negative 1x, or, negative 1x is the same thing as negative x. Just like 1x is the same as x, okay? I just like to keep it there sometimes. Sometimes I don't want to put the -1 there. Sometimes I do. Right now it doesn't really matter, so I can just keep it there. 24 minus 8 is 16. Now to get rid of this coefficient, I divide by -1. When you divide a number by -1, all it does is change the sign. Okay, so x is equal to -16. You can certainly put that back in to check it. Okay, so we have another, oh, that's actually the same one. Let me pause. All right, so this right here is another problem. Now, for this problem, there's a couple different things that we have to do. Okay, so here's one, one side of the equation is totally fine, and the other one's, this side is pretty messy, so we have to simplify it. When you see something like this, first of all, there's multiplication in here because there's a number next to parentheses. Okay. Now, there's also subtraction of a larger quantity right here. All right, so your 27x is being subtracted. You're supposed to subtract this whole thing from 27x. All right, so be really careful about the way that you think about this problem because it's not just minus 3. It's actually minus this whole thing. Okay, so the first step that I want you to do is I want you to change everything into addition. All right, here's keep, change right here. And right here I want you to go keep, change. So you have 27x plus -3 times 2x plus -10 is equal to 23. Okay, now this is going to seem a little strange, but what you have to do is multiply the -3 into the 2. When the -3 is on the outside of parentheses, it means multiply the entire quantity within the parentheses by -3. Right, so the first thing that you want to do is you want to just think of it as 27x plus -3 times 2x plus -3 times -10 is equal to 23. So look at what I did here. I multiplied 3 times 2x and then -3 times 10. All right, so I'll just write a smaller problem. Let's say I have 4 times x plus 8. This would mean 4 times x plus 4 times 8. That's called the distributive property of multiplication over addition. So that would be 4x plus 32. And that's exactly what I did above. Okay, so let's focus on this one. So we have 27x plus, that's -6x, plus +30, right, is equal to 23. Now the left-hand side is still not finished yet because I have like terms. So the 27x and the -6x are like terms. They're not like the 30, that's a constant. So before I start adding and subtracting from both sides, I want to add those two together. 27x plus 6x is going to get me, plus -6x is going to get me 21x plus 30 is equal to 23. Now we want to subtract on both sides. Okay, I'm actually going to put some space over here so that I can finish doing this problem here. Okay, let me just carry this up over here. We have 21x plus 30 is equal to, what was that, -7. Whoops. Is equal to -7. Oh, shoot. Okay, -7. So here, 21x plus 30 is equal to -7. So now we can start, because there's no like terms on this side. Those aren't like, so now I can start canceling from both sides. So I get rid of the 30. I have 21x is equal to Now negative 7 plus negative 30 is negative 37. And then we want to divide by 21. We'd have x is equal to, well, there's no really, that would be negative 1 and 16 over 21. I know that seems, maybe I made a mistake with one of those. If I made a mistake with one of those numbers, you can tell me in the morning, but that's how we do it. So let's just run through what we did here. Okay, first we used keep, change up here to change everything into addition. So that became addition, and this became addition. All right, and then what we did was we distributed the negative 3 into each term inside the parentheses. That was negative 10. All right, and then we multiplied out, and the right-hand side is still equal to 23. I just sort of lost track of this work here. And then we added these like terms together to get 21x plus 30 is equal to 23. And then we started working with the other side of the equation. So we subtract 30 from both sides. All right, and then we have 21x is equal to negative 37, and we divide each side by 21 and reduce the fraction. Okay, so that still might have been a little bit confusing. Let's just take it back and do a couple more examples. Let's say that I had 15x plus 7 minus 12, and that's equal to 4. Okay, let's say that I had this. Now the first thing I want to do is, okay, so we're going to think about this left-hand side of the equation is not cleaned up enough. Okay, before I start adding and subtracting from trying to balance the equation and isolate the variable, what I want to do is I want to try to clean up this left-hand side. So right now I have these parentheses. The trick is, I actually, is there an operation that I can do within the parentheses? The answer is no, because, I can't add these two things together because it's 15x plus 7x, and they're unlike terms. So I actually don't need the parentheses there. So I'm just going to rewrite this without the parentheses. Okay. Now you can see 15 is unlike 7 and 12, but 7 and 12 are alike, right? So use keep, change here. You have 15x plus 7 plus, there's KCC right here, plus negative 12 is equal to 4. Well, 7 and negative 12 is negative 5. Oops, I forgot the x there, so that should have been 15x, right? So we have 15x plus negative 5 is equal to 4. All right, now we can add 5 to both sides, because if I am adding a negative 5 and positive 5, that gets 0. So you have 15x is equal to 9. Right? And if you divide 15 by both sides, you would get x is equal to 9 over 15, which reduces, they both share a factor of 3, so 3 over 5. Okay? Okay, let's try another one. Let's try one where we have to multiply. So let's say I have 8, and in parentheses I have 2c minus 1, and that's equal to 56. Okay, this 8 on the left-hand side is outside the parentheses, so that means I have to multiply it through. That's a shorthand way of saying that you want 8 to multiply by everything inside the parentheses. There are 2 terms inside the parentheses, so I have to multiply 8 by each one of them. So I have 8 times 2, 6, minus 8 times 1, and I'm going to still keep the 56 on the right-hand side. Well, 8 times 2c is 16c minus 8, right, is equal to 56. Now you want to add 8 to both sides. So, because at this stage, right here, at this stage, I can't add 16c and 8 together because they're unlike terms. So, and there's nothing else I can do to clean up the left-hand side here. So I'm just going to I'm going to add 8 to both sides. I can start to try to isolate the variable at this point. That's what I meant to say. Okay, so we have 16 C, and that's equal to 14 carry the 64. And so you divide each side by 16. C is equal to 4. Okay. So let's just review what we did. We took the 8 and we multiplied it by the 2C and by the 1, right? 8 times 2C is 16C. 8 times 1 is 8. And then, since there was nothing else to do on the left-hand side here, there's no other thing that we had to clean up, we started to isolate the variable by using inverse operations. Okay, another problem here. Let's try 5. Oops. Let's see here. 5 times x plus 2 is equal to 20, right? Now, the 5 is on the outside, so that means it's being multiplied. You have to multiply it in. 5 times x and 5 times 2. 5 times x is 5x, plus 5 times 2 is 10, and that's equal to 20. All right, now there's nothing else to do on the left-hand side here, so let's subtract 10 from both sides. I didn't need to write that there. Let's subtract 10 from both sides. I have 5x is equal to 10, divide by 5 on both sides, and I have x is equal to 2. Okay, we could put that back in. We'd say, okay, let's check our work. 5 times 2 plus 2 should equal 20. Well, first I'd do the 2 plus 2, so that's 5 times 4, and that is equal to 20. So 20 equals 20, that's correct. Okay, let's do another problem. Let's say it's 5m minus 2 times m minus 5. That has to be equal to 17. All right, so we have a little bit of work here to do on the left-hand side. Now, remember, the first thing I want you to do is I want you to use keep, change to change all the subtraction into addition. Okay. Now here's a subtraction problem, and after you get that, you're supposed to multiply it by that. So let's use keep, change up here. Keep, change, right? And let's, inside here we have keep, change. Okay, we have 5m plus negative 2. In parentheses we have m, we're going to keep that the same, plus negative 5. And that's equal to 17. Now, look at what's happening here. We have 5m plus. Well, what is it? What are you adding to 5m? You're adding to 5n this whole thing here. Okay, so when you do that, before you do that, you've got to figure out, okay, there's nothing else you can do in the parentheses. Those are unlike terms. You cannot add them. But you can distribute the negative 2 in. So we have 5m plus, let's do negative 2 times m, that's just negative 2m, plus negative 2 times negative 5. Let's carry the right-hand side of the equation down. 5m plus negative 2m plus, now this is going to be positive 10, it's equal to 17. All right, now my right-hand side of my equation is just 17. My left-hand side is this, and I still can add 5m and negative 2m together because they're like terms. Those add together to get 3m plus 10 is equal to 17. All right, let me use a different color here. Now there's nothing else I can do on the left-hand side here. So I can start to isolate my variable. I'm going to subtract 10 from both sides. So I have 3m is equal to 7. Okay, now divide each side by 3, divide by 3. M should be equal to, that's 2 1/3, right? Or 2.3, and the 3 is repeating. Okay, so that's going to be it for today. We're going to talk more about this tomorrow, so just make sure you have all of this in your notes.